Hey everybody, I'm the Linz in Fizz with Linz, and today we're bringing you AP exam tips and tricks. Let's conquer this. Let's get over this. Today's episode is brought to you by coffee. It's what's currently in my cup. Delicious. Coffee. It's what's for breakfast. Coffee. Available at a store near you. Now let's get into it. First tip right off the bat is we need to understand that calm us, focused us, probably is the most prepared, probably is the one that's crushing these questions. So what do we need to do? Stay calm. And there's a little breathing technique called a little 4-4-6. Here's the idea of it. Breathe in through your nose for 4 seconds. Hold that breath for 4 seconds. Breathe out of your mouth for 6 seconds to do it pretty calm. Why don't you give it a try now? I'll count you through it. You just take a second and breathe. Let's really bring the stress levels down. Ready? Breathe in through your nose for 4, 2, 3, 4. Hold for 4, 2, 3, 4. Breathe out your mouth for 6, 2, 3, 4, 5, 6. See, don't you feel better already? I know I sure do. That's been clinically proven to drop stress levels in the body. So do it 2 or 3 times. Doesn't take very long, but does get you prepped and ready for our next tip and or trick. Determine the unit. Look at the problem. If it's an orbit question, we should probably understand that that's probably UCM. If it looks like an oscillator, it's probably an oscillation question. So look for tips in the problem that push you towards what unit. That could really help you solve the question. Also, determining the style might be really helpful. So we want to look to see, is there a graph that I'm using? Right? Is this a question where they're asking me for a numerical value in which I would have to do something to get that numerical value? Are they asking me to read all these sentences or at kid 1 and kid 2? Like, what are they doing? What do they want from me? It's a big thing here is determine the style of question. Next thing is graphs. Is there a graph in the problem? If there's a graph, there's a really good chance you're using it, like a really good chance. So what do we do with graphs? I'm so glad you asked. There are 3 things that we would primarily do with graphs. The first is to read them. Just simply read the graph. Are they asking about a position? And do you have a position graph? Well then, man, that's going to be pretty darn easy to look at. Are they asking you whether or not the force is constant or changing and they gave you a force graph? Well then that's going to be pretty easy to deal with. So just read that graph there. What's the next thing we can do with graphs? Slope. Take the vertical axis, whatever that is, divide it by the horizontal axis, and if that makes sense, then that's probably what you're doing in that problem. If that makes sense to connect to the problem, that's most likely what you're going to do. Great example of that is when we have something like a position time graph, and they're asking about velocity. Well, position or displacement divided by time, right? That would give us velocity. So that's what they're looking for already. If I have a spring in my question and I have a force displacement graph, well, force divided by displacement, that's actually going to give us spring constant for springs. So look for that slope, divide those 2 things, and if it makes sense, then that's most likely what you're going to be doing. What's the last thing we do with graphs? Of course, not to be forgotten, area. Take the 2 axes and multiply them. And if that makes sense, that's what you're doing. So really common example of this is a force time graph, because we take force and multiply it by time. What do we get? You got it. So that's our impulse or change in momentum. So look, things like that, right? If we're given a graph, we're probably using it, and read, slope, and area are the primary things we would do with those graphs. Amazing. What's up next? Well, the next thing for us is our hierarchy of methods, or our home. Home. I'm not ashamed to admit that I typed those 3 letters into Google and found a video of people pronouncing it. I'm not ashamed to admit that. The consensus? Home. What does that mean? Well, when we got a question that we don't know what to do, and it seems too vague or too out there, well, we gotta think, what are our styles of questions we do, and how would we solve things in a physics method? Now, obviously, there's always disclaimers on things. If it's an oscillator, just do oscillations. But if you don't know, this is really helpful. What's the first thing we should try? Momentum and impulse. Momentum and impulse would be the primary thing to try, because that is the one. That is the thing we would love to do. first if we can. Now, if it's not a collision or there isn't a force and a time and a clear impulse, then we head to our next thing, which would be work and energy. Are we at one location to a separate location? Clear indication that's probably energy, right? Can we do that? Now, if we can't do work and energy, then it would break down into either being dynamics or kinematics from there. But primarily, if we don't know, if we're truly lost in a question, we want to try to start with momentum and then work our way down, hoping that we don't have to do dynamics and kinematics, right? Because then we're going to have to do FPDs and charts and all that. So we want to try to avoid that if we can. But that's our hierarchy. So try that momentum, impulse, energy, and then work to dynamics and kinematics. What's next? Well, what do you got? If we're still lost in a problem, we're still stuck, we don't know what's going on, look through and start flagging, right? What did they give me in this question? What are the things that I know, right? Is this a ball, right? Do I know the mass? Do I know the initial velocity? Do I know the height it's starting at? Do I know the time that whatever's happening? Are there 2 objects? Are there 3 objects? What's going on? Start by identifying all those knowns. Hopefully, if we start writing down or underlining or circling all our known values, it should hopefully kick in a little bit as to what we should probably do. And then finally, think, what would we do, right? Look at these questions and try to think back to what you've done before. At this point, you've done a lot of questions. You've done a lot of problems if you're preparing for an AP exam. So if we're in that, what would we do? As physics people, what would we do to solve a question like the one you're looking for? Now, this doesn't always work, but sometimes you might have seen a homework or some weird question like this before in the past that could really be helpful. Now, the big thing for us, we want to stay focused, right? We want to be thinking about these, and these are some little things to push us further. And I'll tease something for you in a moment. Something coming your way real soon, maybe. Oh, I don't know. I think some things are earned. Is imagine if all of this and more was available in Lindley's sheet of helpful things for great success in AP1. Oh, look at that. Blurred out. Oh, yikes. Spicy. Look for that maybe in the near future. Who knows? Maybe it won't happen. Who knows? I hope you found this helpful. If you're looking for more exam tips and tricks, smash that like and subscribe. Hit the bell. And as always, until next time, kiddos, this has been PhyzWithLindz. Peace out.